Okay, in this video we're going to talk about graphing inequalities in slope-intercept form. So we're going to be graphing these inequalities on the coordinate plane. When we do this, when we have inequalities that are in slope-intercept form, I recommend this process. First thing that I always do is I determine if the boundary line is solid or dashed. And I do that first because if I know what the boundary is before I graph it, then I don't have to, scribble over lines or erase or anything like that. I know I want a dashed boundary or a solid boundary before I actually graph the boundary line. Anytime you have an inequality containing an equal, that's going to relate to a solid boundary, and anytime there's no equal on those inequalities, it's going to be a dashed boundary. This is identical to the concept when we graphed inequalities on a number line. We had open circles and closed circles. We had closed circles when we had equals portions on the inequality signs, and we had open circles when we didn't. Remember that the closed circle means that that's part of our solution, and the open circle means that it's just a boundary to our solution. Same thing on the coordinate plane. The solid line represents the points on that line are solutions to the inequality, whereas the dashed boundary just means that that's a boundary line. Everything up to that line is part of the solution, but not anything on that line. Then the second thing I do, since it's in slope-intercept form, I use the y-intercept and the slope to graph the boundary, and I either graph it as solid or dashed based upon my conclusion from step one. And then the third thing I do is I determine where the shading should go. So if y is bigger than, greater than or equal to, or greater than what's on the right-hand side of the inequality, we're going to shade above the boundary. And if y is less than or equal to, or y is less than, we're going to shade below the boundary. And that's really everything that we could possibly need to know about graphing an inequality in slope-intercept form. All right, let's look at a few examples here. First example, we are going to graph y is greater than negative 3x plus 5. So first off, I look at this inequality sign. And that inequality sign tells me two things. It tells me that this is going to be a dashed boundary, since there's no equal to portion. It also tells me I'm going to shade above that boundary when I get to shading. But first I need to draw the boundary. So I'm going to plot the y-intercept. Y-intercept is positive 5. And then I'm going to use the slope. The slope is negative 3, which means from that y-intercept, I'm going to go down 3 and over 1 to the right, plot another point, and I'll do one more, down 3 and over 1, plot a point. And now I want to draw a dashed line through that, so I break out my handy-dandy ruler and make it a dashed line. I'm going to draw a dashed line through those points. And when I do this, I want to draw my boundary line from one end of the plane to the other so that it clearly divides the plane into two halves, the half that is below the line and the half that is above the line. And realize it's as easy as going to this line and going, okay, I want to graph above. If I start at this line and go up, that's the side of the boundary line that I want to shade on. And so I'm going to shade up in here. And there's my graph of y is greater than negative 3x plus 5. All right, next example. Y is less than or equal to negative 1/3 x minus 4. First I look at the inequality sign. That tells me that this is going to be a solid line. And then I'm going to plot the boundary line. Got a y-intercept of negative 4. So I plot point negative 4 on the y-axis, and then I've got a slope of negative 1/3, so I'm going to go down 1 and over 3 to the right, down 1 and over 3 to the right, and then I want to draw a solid boundary line through these points. So I'm going to draw a solid boundary line through those points. And now let's see, my inequality sign is a less than or equal to, so I want to shade below the line. So I can go to any point on the line, and if I go down from that point, That shows me what side I want my shading to be on. So I'm going to shade down here. And there's my graph of y is less than or equal to negative 1/3 x minus 4. By the way, you don't need to draw that little arrow in showing which side is below and which side is above. I just do that to help it make it a little easier for you to see in these videos. Alright, one more example of graphing an inequality in slope-intercept form. Y is less than 2/3 x plus 5. We look at the inequality sign. It tells us it's going to be a dashed boundary since there's no equal to portion. And then we're going to draw the boundary. Let's see, y equals 2/3 x plus 5, y-intercept at 5, and a slope of 2/3. So I'm going to go up 2 and over 3 to the right, up 2 and over 3 to the right. And then I'm going to draw a dashed boundary line through those points. Using my ruler, there's my dashed boundary, and the shading should go below. So I'm going to shade in down here. And there's my solution to the inequality y is less than 2/3 x plus 5. Now on a side note, just a reminder of what this means. When we shade in this region, that means that if I pick any point in this region, say I pick the point 5, 3, that's in the shaded region, if I substituted that point into the inequality, it would make it a true statement. And that holds true for any point in this shaded region. If I pick any arbitrary point in this shaded region, they are all going to be values that if I put them into this original inequality, it's going to make a true statement. If I pick any points that are not in the shaded region, it's going to not make that original inequality true. Just a little refresher on what it means, why these shadings happen, and what they indicate. All right, that's the end of this video on graphing inequalities in slope-intercept form. See you next time.